these are the two rings, no? So here they say, what is the charge? A has positive charge. So that this is QA, you write it. What about B? Well, B has negative charge minus QB. And this distance is H. Let me take here. This you call O2. This is O1. So here I'm going to release a charge particle called Q. What are the forces? G is also acting. He has given G. You can see at the bottom, the weight mg will act. And this will exert a force, no? Electrostatic force. F2. So check first F2 greater than mg. So definitely saying calculate velocity per when it reaches here means F2 will be greater than mg. So it starts accelerating. He's asking now, what is the velocity when it reaches the point O2? When the same charge particle reaches here, what will be its velocity? The rings are fixed. So when the same charge particle arrives here, it will have velocity v2. Here definitely F2 greater than mg. That in option 1 you work out here. Acceleration should be F2 minus mg, you can write it. What is F2? F2 should be equal to now how to calculate the acceleration part? Acceleration part is equal to A is equal to F2 minus mg by m. What is F2? How to get the F2? F2 should be equal to QV into E2. What is E2? K QB H by root of radius of the ring. Radius of the ring given A. Electric field due to ring formula is what I'll be using. Fine. So this is the value of F2. So definitely the F2 will be greater than mg. So therefore it will have acceleration upward. So you call that as A naught. The acceleration here will be this one. Okay, let's come for the getting the V2. Why there is no force by the lower ring? Because it is at center of the ring, no? So force exerted by the lower ring A will be 0 on the charge particle initially. Then the force F2 will be greater than mg. It starts moving up. As it starts moving up, what are the forces? Somewhere arbitrary point will take it. Electrostatic force F2 dash will be like this. And even F1 dash also, no? And why both are upward? Because of the field due to this ring, E1 will be like this, E2 will be also upward direction. The field produced at both the rings will be in same direction. So therefore the electrostatic force what happen will accelerate it. The mg what happen will retard. How to calculate V2? So shall we take help of the integration method? No, we can directly take help of the conservation of mechanical energy or work energy theorem. So when it moves from the point O1 to O2, O1 to O2, which all forces does positive work? Electrostatic force does positive work, and whatever the weight does negative work. So initial kinetic energy at O1 plus work done by gravity, work done by electrostatic force should be equal to kinetic energy. It is released from rest, work done by weight minus mgh plus. How to get the work done by electrostatic force? Work done by electrostatic force in moving a charged particle from O1 to O2. O1 to O2, sure. We'll write like this. Huh? It should be equal to m v2 square. Further, uh, this is no problem, minus mgh. What about this? How to get this one? This should be equal to directly q into potential at point 1 minus potential at 2. We are trying to avoid that integration method. That's all here. How to calculate potential at 1, VO1, due to QA, K, QA by A. And where do that O1 will lie on the axis of the ring B? So there should be equal to minus QB root of A square plus X square. So what is the potential at the center of the ring? There should be equal to K minus QB by A plus KQA. Substitute those potentials, you get the required answer. So there's a maximum, what's happened? Take help of that energy method. And here, why we brought the idea of potential? Because whenever charged body comes, so we do take help of potential to express that interaction potential. Nothing but what is WEL? What is Q into VO1 minus 2? It's the interaction potential only, change in interaction potential only. So what will happen here now? The decrease in interaction potential G will get converted into increase in kinetic energy of the particle plus increase in gravitational potential. That's what the equation is. So just everything in the form of like work energy theorem, we have put it. If you want, you can write conservation of mechanical energy also. Since I just prefer work energy theorem because any conservative, non-conservative would be applicable. So you calculate, no, here the answer is given 8 meter per second. So this V2 will be, this will be our answer. So like this, what happens? You do get many problems where the point charge will be moving nearby charged objects. So immediately open, you are going to bring the help of the interaction potential or the potential concept here. Okay, we'll take 10 minutes is there. We'll